And today's training is about our new C&I battery, the EBR-A series. And if you have any questions during these introductions, you can interrupt me at any time. Okay. Okay. And about contents, and it will include the overview, the key parameters, the application, the installation and wiring, and the certification. Okay. First of all, about the brief introduction, and this series is it is high voltage LFP battery, so it will have the features of the high voltage battery, like the high efficiency, like maybe the powerful output power and input power. And it also have the intelligent BMS, and because it's high voltage, the BMS is very important. So it can provide a comprehensive protection, like the overcharging, over discharge, over current, over voltage, or the extreme temperatures to detect some features like this. And this battery series is designed for the C&I. So you can see it can compatible with our C&I inverters, the MHT 50 kilowatts. So it has 100 maximum 100 ampere charging and discharging current, and it can support. You can see the one cluster. It can support 6 to 14 battery modules, and it also can connect it in parallel. It can support up to 8 clusters in parallel. So the whole storage capacity can be extended to the 600 kilowatts hour. So it will be very suitable for some C&I applications. And about some module specifications, the cell capacity is 105 ampere hour, and the capacity of one module is 5.37 kilowatts hour, and the voltage is 51.2 volt. Okay. And about the highlight of this series, I have mentioned it has a flexible combination and matching, and one cluster can support 6 to 14 modules in one cluster. So the voltage capacity can from the 300 to the 700. It can suitable between our MHT inverters, MHT 50 kilowatts inverters, and it also can use this parallel box to connect in parallel up to 5 cluster connecting in parallel with this one, the parallel box. So the capacity range can from the 32.2 to 200 kilowatts hour, and with up to 100 ampere charging and discharging current. And about the warranty, it has the two standards. One is the 10 years warranty, and another one is about the throughput. What is the throughput? It is the total output of the battery, and the calculation method is use the capacity of the battery to times the 3.2, and the result units will be the megawatt hour. For example, if I use I choose the 75 kilowatts hour battery, and the throughput will be 75 times the 3.2 will be the 240 megawatt hour. And the two standards, one of the two standards is reached, the warranty will be expired. Okay. And next, about the cell level detections, and it provides the cell level protections and has the passive balancing technologies for the precise cell status, and they also can remote configuration and upgrading through our Solinteg Integ Hub application. Okay. And here you can see the appearance of the whole system. And this one is the 75 kilowatts hour with one controllers and the 14 battery module. And here is the parallel box here. And if the customer just need the one cluster, don't need the parallel box. I just show you the appearance of the parallel box. And about the rack, here you can see the rack. It is the EBR-A8, and it is the different numbers of the battery modules. We'll use the different type of the rack. And the A8 can be used for the 14 battery modules, and I will talk about it later, more detail later. Okay, here you can see the parallel box and the controller and the battery modules and the rack like this. This is the components of the whole system. And next, this more detailed information. Here is the controller. The weight is about 23 kilogram, and about the battery here is 49 kilogram. And you can see the dimension. The controller is just a little higher than the battery module. You can see here a little higher. And this one is a parallel box, and the parallel box includes the parallel. You can see here, this is the parallel, and here is the power supply circuit to provide the power source to the parallel. Okay. And next about some parameters. And here shows the parameters of the whole system. You can see the module numbers from 6 to the 14. And about the naming row, the E is the extender, and the B is the battery, and R is the rack, and S is the stackable, and the number is the capacity of the system, and K is the kilowatts hour, and A means the A series. Okay, and next, there's something we have talked about. Here is the third port. You can see the times 3.2. Okay, and here the battery just has IP 2.1. The 2 means the it can protection against the maybe the solid within 12.5 millimeters, and the 1 means it just can protect the water vertically to drop from the top. Okay, so we just recommend it for the indoor installation. Okay, next about the parameter of the controller. Here you can see the operation voltage of the controller is 250 to 1000. This is why we suggest the system need to be used from the 6 pieces, because you can see the 250 volt. The user also can use the 5 pieces, because one pieces is the 51.2 volt, so 5 pieces the nominal voltage about 255. But the working voltage will be dropped below the 250 volts. So if the customer want to use the 5 pieces, we need to set a low at DOD, a low DOD, just about 60%. It is very don't have a high cost effective. So we suggest the customer to use this system from the 6 pieces. Okay. Okay, here you can see some button and the terminals, and from left to right, here is the start button, and here is alarm indicator. Here is the positive socket for the inverter. There is the negative for the inverter. Here is the digital input and digital output reserved. It is reserved. It is not be used now. And here is AGDR for the physical address of the controller. And here is the CAN2 port communication with the inverter. And here is the CAN1 port communication with the battery. And here is the breaker, and here is the status bar to show the working status and the existing capacity. And here is the grounding port, and here is the positive socket connect with the battery module. And here it is negative, and here is a 24-volt output port to connect with the fine. To battery modules will have the fine to heat dissipation, so it can need the fine, need to connect the fine. And here is the operator port. It is a debugging port. Okay. And here is the parameter of the battery module. And here we have talked about. Here you can see from left to right, here is the fan, and here is the fines power in. Here is the fines power out. Here is also the grounding. And this one is the positive socket of the battery, has the negative. Here we have a activation button and power switch. And here the first and the second one is the CAN port, CAN A and CAN B. A and CAN B. And the last one, it is a debugging port. Okay. And here you can see this is a parallel box and the parallel. You can see here the whole one is the parallel box, and this one inside of the box, this one is the parallel. And you can see the box include the parallel and the power source circuit to provide the power to the parallel and the power button. Okay, you can see here the circuit include the AC cable terminal and AC-DC converter. Because you can see here, and the parallel, it need a 24-volt DC, but the parallel box is designed to connect with the backup side, so it is the 250-volt AC. So the circuit will convert the AC to DC and step down the voltage from the 230 to 24 volt, and then supply the power to the parallel. Okay. And here you can see the terminal. Here is the power source terminal, and here is also the reserve digital input and digital output port. And then here is the CAN port to inverter. As here CAN port inverter and CAN COM port to controller. And here we have two debug ports. And this one is the run button and alarm LED. Okay. Next is about the rack. I have mentioned the different number of the battery modules will use the different type of the rack. We have the three type. Now we have the three type, the AT8, A6, and A8. The T you can understand like the single row. That's just single. And without the T, you have the two rows. And the 8, the number you can understand like the number of layer. You can see here the 88, it has one row with 8 layers. 1, 2, 3, 4, 5. Yeah, 8 layers. So it can accommodate 1 controllers and 7 battery modules. So the 6 to 7 pieces battery modules will use the 88. But the A8 is an exception. You can see because now we just support the 14 pieces, so you can see the controller and we calculate it can accommodate 1 controller with 15 battery modules, but we just support the 14. So this one we will block it. Okay, so it can 1 controller and 14 modules like this. And here I list the capacity range. You can find it immediately. Okay, next part about the application. And okay, and if you use the single cluster, you can just use it like our normal battery, the CAN communication between with the inverter and some functions the inverter's features. Okay, and but if you use the multi clusters in parallel, you need the other two external device, the parallel box we have introduced, and the power combiner. And now the parallel box will be provided by the Solinteg, but the power combiner currently needs the clients to self-purchase based on the number of the cluster. Okay, and here the parallel box need to be power supplied through the backup side, and the power combiner is sorry. Okay, the power combiner is responsible for the power for the power cable. I see the power cable, and the parallel box is for the communication cable. Okay, and next about the installation and the wiring. And the first one, I need to introduce that the installation and the wiring in this document, I choose the A8. So if the customer buy the A6 or the 88, it will have the different size of the components and the different numbers or size of the accessories. Okay, so it's just you need to refer to the actual accessories received and the installation instructions. Okay. Okay, and the step one need to unpack, and then you will find the pillar, the trees, the cross pieces, and the decorative cover, the beams, and the P bar, and some different types screws. And the step two, you can fix the pillar, the pillars and the beams like this, and fix it by the screw. And then you need to fix the pillars onto the ground by the expansion screw like this. And next, you need to install the tree in the most bottom, and then install the PE bar like this. And then you will get the finished one, the finished look like this. And it will finish the rack installation. Next, install the controller and the battery. It is very easy because the hole is pre-drilled. You just need to put on the first layer. Yeah, yes. The controller need to install to the first layer because I have mentioned the controller is higher than the battery modules. So the first layer will also higher than other layers. Okay. First step to put on to the first layer and fix it. And the battery is similar. And install it one by one like this. And then use the decorative cover to block this layer and use the core pieces to fix this rack. And finally, you'll get this one. Okay. And next, if you use the multi clusters, you will receive the parallel box and with the cross rail. The first step, you need to hold the two things by the screw, the cross rail and the parallel box, and then hung this one to the side of the battery rack, this side. Okay. And okay, after the installation, about the wiring, and first of all, we have some notice before the wiring, and for the single clusters, you need to the whole battery modules need to be the same characters, such as the SOC, the batch, and the storage time, and the storage system must to be start or restart after changing the ADDR. Okay, this is important. And next, first, we need to control the inverter. Sorry, we need to connect the inverter to the controller. The blue line is the power cable, and the orange one, the yellow one, orange one is the BMS communication cable. So we need to connect the battery, the BAT plus to the P plus of the controllers, and the minus to the minus, positive to positive. And here we'll use the COM2 ports, BMS port, COM2's BMS port, connect to this one, to the CAN2A, CAN2A. And about the ADDR, the DIP7 needs set as the on, and others will be off. Okay, and next, from the controller to the battery module, and the first about the power cable, need to plus the B plus to the B plus from of the controller to the B plus of the module, and the B minus of the controller need to connect with the last battery module's B minus. Okay, and the battery module's B minus need to connect to the next module's B plus. Sorry. Okay, and the orange one is communication one. You need to from the CAN, it is a CAN 1B, yeah, CAN 1B from the controller to the CAN A of the module, and then from the CAN B to the next module's CAN A. And the red one is the power cable of the fan. Need to from the 24-volt output port connect to the power in, and here is power off of the fan. And the green one is the grounding. Just need to connect one by one, connect the terminal one by one. Okay. And that's about the modular between the modular, module between the module. And here you can see the blue is cable, power cable from the minus to plus and minus to plus, and the red one is the fine power from the power in to power out like this. And if the last one is if this one is the last battery modules, and the power out need to connect back to the 24-volt, the 24-volt output port. Okay, and the green one, the grounding line, the grounding cable need to connect to the PE bar, and the cable, the power cable, need to connect to the controller's B minus, negative. And here is the communication cable, just from the CAN B to CAN A, and to the last one. It is over. Okay. And here is the overview of the wiring. The left one is the power cable and the grounding cable, like this. And this one is the communication cable, the orange one, and the fine power cable. Okay. And here is some actual wiring diagram, and I took some photos. And here you can see the two power cable connect to the inverter. Here this one is controller, this one is module, and B plus to B plus like this, and this one is the grounding, and this one, black one, let's see, from the 24 output port is the fan power, and the blue one is communication, and here's module to module. You can see the connections. Okay. Okay, and next is about the multi-cluster. And it is same. The characters of the battery modules in each clusters must have the same characters like the SOC, the bench, and the storage time. And besides of that, the cable for the parallel connections of each clusters must be the same, like the length, the materials. So please make sure use the cables provided by the Solinteg in the package. And about the address, about the ADDR, and must strictly follow this table to set the ADDR. And the DIP of the last controller must be set as on and off for the rest cluster. Okay, this is very important. Okay, next, the wiring of the power cable or the communication cable in one cluster is similar with the single cluster. So, but we have another two device, the parallel box and the power combiner. So we need to know how to the wiring of these two devices. And about the parallel box, the first you need to connect the parallel box with the controllers. Just need to this page shows the first show the communication cable. Here you need to connect this one is the CAN port. Connect with this one is CAN2A, CAN2A of the controller, and from the CAN2B to connect with CAN2A of next controller, and then one by one connect like this. And about how to connect the inverter with the with the parallel box. First one is about the power source. Power source just need to connect with the backup side, and it's a take a single phase, and like this connect with this one is the AC terminal, and then it will convert AC to DC to power supply. And about the communication cable, just to take the COM2 port, the BMS port from the COM2 port to this one. This one is the maybe the CAN inverter, yeah, CAN inverters, and then from this CAN controller to connect to the next controller one by one. Okay. Okay. This page shows the overview of the wiring. Okay, like this, and it can support up to 8 clusters. And about the battery power combiner, yes, it is now currently we don't provide this device, so the clients need to self-purchase and based on the number of the clusters. And here we provide a selection reference. We provide to select the DC break. Here is the nearby the battery DC breakers, the 1000 volt and the 225 ampere. And the breakers nearby the inverters, we suggest to use the 1000 with the 25 ampere or the 180 ampere. Okay, and here I draw a wiring example, and this example just show the 4 clusters in parallel. Okay, so the power combiner just have the breakers with the 4 input and 2 output. And but if you maybe use the in the parallel with the 8 clusters, you need to choose a 8 input and 2 output like this. Okay. Okay, the connection like this, the P plus of the controller with all the positive connect to one breakers and all the negative connect to another, and then use a bus bar, and then we have a main breaker between the inverters and power combiner, and then connect to the battery port, yeah, the BAT port of the inverter. Okay, here is the overview of the power cables. and it also support up to 8 clusters, like this. Okay, next one about how to start up. And before, we also need to know something like, yes, here, if one or more modules do not turn on automatically, you need to turn off. You need to turn off the whole system and to check the connections and then restart the startup procedures. It means if one or two or more modules do not turn on automatically, you cannot just restart this module. You need to turn off this whole system and to check and then restart the whole system. Okay. Okay. And yeah, this one also. And if before you restart, you need to off the breakers between the inverters and the battery. Okay. And here is the procedure. The first one, you need to turn on the all switches of the modules. The all switches of the module turn on, and then turn on the breaker. Push on the breaker, and then press this start button, maybe 3 to 5 seconds, and it will be turn green, and it shows it is starting. And the next step, close the breakers between the inverters and the battery. Okay, and here you can see do not press the activation button, and this one is the restart button, and do not just restart one battery modules. Okay, and the last part, the certification. Now this battery has the battery like this, the CB50, as the certification of the grid code, the grid safety, and some maybe the EMC and the LVD certification. And this one is about the delivery. Okay, and the certification is continuously being updated. And if you want to know more things about the certification, you can connect with our maybe your directors, self-directors, and maybe our certification engineer. Okay. Okay, this is the whole content. Do you have any questions?